So, sampling. Sampling, by and large, most of the time is naturally biased. Ideally, if you want a sample that is truly representative, then you really should go for a stratified sample. And you think back to GCSE days, the concept of stratifying your sample so it is representative was better, but Hugh isn't doing this. Hugh's standing in the town centre and he's asking about 120 people, albeit over several days, which is not bad, but not great. So the main sorts of sampling that you've got on your Unit 2 syllabus are simple, random, systematic and opportunity. So this is clearly the third sort, opportunity. I'm not going to write this because one of my colleagues will do a Welsh voice over here, so if anything I write anything in English, then it's going to create a bit of a problem there. So, and obviously that particular colleague will edit what I've put here, but so what we're looking at in this particular case is opportunity sample. He just happens to be loitering on the street talking to people who come along. He's not going out with a particular frame in mind or things like that. And these sorts of questions, how could it be improved? Well, he's looking in one area, so you could suggest that he goes to different areas. You could suggest that he certainly asks more people at different times of the day, although it doesn't say anything about times of the day. But generally, if you want to improve your sampling technique, you need to ask more people. If you want your sample to be truly representative of the national population, then you actually need to be asking more than 1,000 people that are representative of the true population. So therefore you should be stratifying by gender, age and things like that. But the question is not about stratification, it's about improving this opportunist one. And so therefore you really need to be looking at different areas, more people, something along those sorts of lines. Diagram here where you'd expect that the more people you have living in an area, the more primary schools you're going to need. That's not unreasonable, and all this graph is showing you is that there is a rough positive correlation that as the population gets bigger, then the number of people or the number of primary schools that you need will also generally be bigger. Not exclusively so, but generally so. But also this diagram is just to confirm that. He's looking for a relationship, and at this level in Unit 2 we don't actually have to calculate the regression coefficients and things like that. If you were doing further maths Unit 2, you would be in a position where you were having to calculate those sorts of things, but it's not within the scope of this syllabus. And obviously when you get onto university and study later on, there are many programs such as R which will actually calculate the regressions for you. So ANOVA, analysis of variance, will also do it. So there's all sorts of different ways of finding these sorts of things without having to crunch numbers yourselves. So we're given that the number of primary schools is 22.7 plus 0.2406 times the population of the county. And the important thing to notice there is that the population of the county is measured in thousands. So limitation of this regression line would actually suggest that if your population was 0, no people, that there'd be 22.7 schools required in an area with no people living in it. Well, clearly you don't have areas with no people living in it, but when you're talking about limitations of regressions, you need to be thinking in terms of this concept of interpolation. It is valid between the sorts of numbers we get on the original graph, which took us from about 100,000 people to 2.8 million people with an appropriate number of primary schools. What happens if you happen to live in an area like, say, Ceredigion or Powys? The population of Ceredigion, for example, at the moment is expected to be somewhere around 74,000 or 75,400 people. You can't apply this rule to it because the rule is based on data that comes from a larger set. You're extrapolating outside the unit, so therefore that's part of the problem. But if you let the population be 0, then the number of schools is going to be 22.7 plus 0.2406 times 0, which means that you're going to need 22.7 schools, which clearly is silly. Now, you notice that I originally, so when I'm coming on to an estimate for the number of primary schools and population of 889,000 people. So therefore, my number of schools is going to be 22.7 plus 0.2406 times 889. This is a very important. If you didn't read the question, you're going to get a very silly answer. And there's no good pressing buttons on a calculator if you don't think about the answers you get from it. So if you hadn't read that bit of the calculator and you put in 889,000 and multiply it by 0.2406 and then add 22.7, you'll get a really silly number of schools. And at that point, your brain should start fuzzing a bit and you should go, no, this can't be right. So using my calculator, and it's most unusual for me to actually use one, I want to do 0.2406 times 889, and then I want to add 22.7 to that. So I reckon I get 236. 236.594. It would be reasonable for me to round that up to 237 schools. I would personally say I'm a pure mathematician, but I also do statistics. That correlation does not necessarily imply causation, because in some cases it does. In this particular case, you could quite reasonably say that a larger population will be caused, or will cause, a larger number of primary schools to be necessary. So therefore there is a causation effect in this particular case, which is why this correlation does not imply causation type of thing. It doesn't necessarily mean that is the cause of it, but it is reasonable to expect that if your population increases, you need in time to increase the infrastructure that deals with that increase in population, and the time frames actually are generally such that you can do adequate planning in order to get those things into place. House building doesn't happen overnight, and families moving into that area don't suddenly flood in with huge numbers of additional children, but over time there will be families coming in, with younger families coming in, who will need more facilities, so therefore there will be a requirement for primary schools, but that happens in planning terms. So Again, I'm not writing anything at this stage because it is joined up writing. My numbers are bad enough now. You want to see my joined up writing. So, but it's the actual thing that I'm saying there. So there's a whole bunch of different comments you could make in this. That along the lines of there is a cause and effect type approach on this because of the nature of the situation. If we increase our population, it doesn't immediately increase the number of schools required, but there is clearly a relationship going on there.